So let's consider Archimedes' principle, which states that an object partly or wholly immersed in the fluid will experience a buoyant force equal to the weight of the fluid displaced by the object. So it's equal to the mass of the displaced fluid times g, which is equal to the density of the fluid times the volume of the fluid displaced by the object times g. So in this case, when the object is fully immersed, the resultant force of the buoyant force minus the weight is given by this equation. And here the volume of the object is equal to the volume of the displaced fluid. And in the case of a floating object in equilibrium, the buoyant force is equal to the weight, and the volume of the displaced fluid is not equal to the volume of the object, and this gives this equation. So suppose you have a piece of wood which has a density of 0.6 grams per centimeter cube, and you push the block completely underwater, and this is the water density. So as you can see, wood has a lesser density than water. So this is the equation when the block is accelerating upward or downward, and this is when it's floating in equilibrium. So now suppose after you push the block underwater, you release it. So let's see what happens to the block. So the block will accelerate upwards, and as it emerges from the surface of the water, less volume of water is displaced, and so the buoyant force will decrease gradually until it becomes equal to the weight, where then the block will float in equilibrium. But how it slows down, it can overshoot slightly and then bob up and down, but finally settles into this equilibrium, floating with a fraction submerged. And of course, as the block moves upwards, there will also be a drag force from the water, but it will not determine the final floating position, but will reduce the acceleration and damp the oscillation before equilibrium. But if the velocity of the block is small, then the drag force is small and can be neglected. So when it's floating, B is equal to W. And from this equation, you can find the percentage of the block that is submerged in water. So 60% of the block is submerged and 40% is above water. So now let's see how the submerged percentage changes if we change the density of the fluid, such as we add salt to the water, and if the water is very salty, its density is 1.2 grams per centimeter cube. And then the submerged percentage will change to 50%. So now half of it is underwater. So now suppose the density of the block is larger than the density of water, then the block will accelerate downwards and sink to the bottom. And then there is the added normal force at the bottom that will keep it in equilibrium.